In this segment, we're going to look at reviewing DORA and DHCP in general. Why is this important? Well, DHCP, Dynamic Host Configuration Protocol, is a commonly used way for your clients to be dynamically assigned IP addresses and other information such as DNS server settings. If you're still using WINS in any name, shape, or form, it will provide that. It can provide a gateway information. It provides the basic IP information needed for a client to participate on a network. And why Wireshark can help you with this is that there are problems with this at times, and understanding DORA, which is the actual process the packets take, which we'll take a look at in Wireshark, to have a client ask for, ask for and receive an IP address. So there's other factors involved. There's lease times. There's the fact that it's broadcast based, and you may have it crossing a router, and if you don't have an IP helper address configured on your router, it may not work. So there's a lot of reasons why it's important to understand what DHCP is, understand the DORA concept, and what it will do for you. So in sum, DHCP used to dynamically configure hosts on your network. It's the de facto standard. It's an option of boot P, and it functions in a way where if you set up a DHCP server on your network, clients will request IP addresses from it, and if it's configured correctly with the correct information, we'll assign that IP information to that client and allow it to participate on the network. So what is DORA? DORA is the packets that go back and forth from the client to the server in the process of giving it that information. So you have a discovery packet, an offer, a request, and an acknowledgement packet. And you can use Wireshark to capture DHCP from client to source to destination server, the DHCP server, to troubleshoot connectivity issues. So what could some of those be? Well, as you can see on the diagram, there's a couple of things that can happen here. For one, as you can see in the diagram, the client is on a segment, and it's asking for an IP address, and it needs to traverse a router. Now, routers by default will not pass this information, so in order to do so, you will need to configure a relay, what's called a DHCP relay agent, and that is known in the Cisco world as an IP helper address. And it will point it directly to the correct DHCP server that will then send the packet back and be able to give it to the client so that it can get its dynamically assigned information. So that being said, if we look at the actual capture, we can see quite simply that we have a discover packet, we have an offer packet, a request packet, and an acknowledgement package. So what essentially is happening here is the source does not have an IP address at all, and it's requesting an IP address. So the client IP address is all zeros, and it's asking the DHCP server from the source port, boot P, 68 to the destination of 67. It's asking, I don't have any IP address information. I am going to all F's broadcast out and try to figure out if there's a DHCP server out there for me to participate with. It will respond back with an offer, okay, and you can see down here the specific options, and then a request packet back for the IP, and then the actual acknowledgement. And through this process, you can see here that if there was something problematic within it, For example, if you had an issue where you did not have the router configured with the relay agent, if you were doing a capture on both ends, you could quickly find that you did not have this set up, and the packet was never getting to the DHCP server across the segment. So that is one simple way to find if you have a communication issue. And the communications review would be if the DHCP client sends the request, broadcasts it on the network, and the DHCP server responds, then you did not, you either had the relay agent configured or it was local and wasn't passing a router. You would see that on the local segment, or you would have to look inside the router to see if you had an IP helper address configured, or you can go on either side of the router and run the capture, and if you're on the other side of the router where the DHCP server was living and you did not see discovery packets, then it's quite possible, or you did not see the request for the DHCP server to send the information back, it's quite possible that it is misconfigured on the router. So remember, communications review, the client will make a request for an IP via a broadcast. The DHCP server on a local segment will reply back. If it's on a separate segment, the router will need to participate. It will need to act as a relay agent. Remember that routers do not do this by default. It will have to be configured. And you can watch DORA, discover, offer, request and acknowledgement, each step, so that you can check the capture to see if in fact this did work. And the relay agents is used to pass the broadcast, facilitate the communication, facilitate DORA from the client to the server and back by bridging the communication and allowing it to communicate from the client to the server by providing an IP helper address and or a DHCP relay agent. And as a review, you can check your discovery packet, your offer, your request, and your acknowledgement to check in to see exactly where it's sourcing from, what the destination is, if it's responding. If you're only seeing discovery packets and you're not getting offers, then obviously there's a break in the communication. And or if you're looking on the DHCP server side and you're not seeing a request from a specific address, then it's likely it's not passing that traffic.